Hello and welcome to my channel Physics with Fun. Here we discuss the basic concept of physics. In today's video, we'll learn about energy and the types of energies. Basically, energy is a capacity of a body to do work, and the types of energies are kinetic energy, potential energy, heat energy, sound energy, electric energy, solar energy, and wind energy. In our syllabus, we discussed the first two major forms of energies, which are kinetic energy and potential energy. So, in this video, we cover the topic of kinetic energy. So, let's get started. The very first topic of this unit is what is kinetic energy. We know that the energy is a capacity of a body to do work, and the kinetic energy can be defined as the energy of the body due to its virtue of its motion. Also, the formula for kinetic energy is half mv square, where m is the mass and v is the velocity of that object. Let us take a look on the derivation of the kinetic energy. Suppose an object of mass m is placed on a surface. Before applying force, its initial velocity, which is u, is 0, and after applying force, the object gets some velocity. Let's take that velocity as v. In this case, u is the initial velocity, which is 0 because the object at rest, and the v is the final velocity which approaches any value after applying force. Let's find out work done first, which has the formula W is equal to F dot x, and the value for force is equal to mass into acceleration. Now put it in the equation. We have W is equal to ma into x. Here x shows the displacement which object get after applying force. So this is our first equation, which is W is equal to ma dot x. Also from third law of motion, which states that the square of final velocity minus the square of initial velocity is equal to 2a into displacement, which will be in our case is v square minus u square is equal to 2ax. In this case, we assume the initial velocity u is equal to 0. Then we have equations such as v square minus 0 is equal to 2ax. And this will be our second equation. If we further solve this equation for x, then we have x is equal to v square divided 2a. Now put this equation value of x in equation first, which is w is equal to max. The current equation we have w is equal to ma v square divided 2a. By cancelling a to a, we have equation w is equal to half mv square. Here we have equation in form of w, as all the work done here converted into kinetic energy. So this is our formula for kinetic energy, half mv square. The next important topic in this unit is relation between kinetic energy and linear momentum. As we already know that kinetic energy is equal to half mv square, therefore by multiplying and dividing this equation by m, we have kinetic energy is equal to half m into mv square divided m. Also, we know that the linear momentum is the multiplication of mass and velocity. Therefore, the formula for linear momentum is equal to rho is equal to mv. By putting the value of rho in this equation, we have kinetic energy is equal to rho square divided 2m. By further solving this equation for rho, we have rho is equal to under root 2m into kinetic energy. From this equation, we clearly see that the linear momentum is directly proportional to the square root of kinetic energy. So this is the relation between kinetic energy and linear momentum. Our next important topic is work energy theorem. This theorem states that work done is equal to the change in kinetic energy of a body. That is, W is equal to final kinetic energy minus initial kinetic energy. As we know that the third equation of motion is v square minus u square is equal to 2as. Let's take 2. In the left side we have v square minus u square divide 2 is equal to as. Now multiplying by m both sides we have 1 by 2 mv square minus 1 by 2 mu square is equal to mas. As we know that ma is a formula for force, therefore we have half mv square minus half mu square is equal to F dot s. By the way, S here represents the displacement. As we clearly see in this equation that F dot S is the formula for work done, therefore we have work done is equal to kinetic energy final minus kinetic energy initial. This is all about the work energy theorem. In the next video, we study in detail our next very important topic, which is potential energy. If my videos are informative and helpful for you, then please like, share and subscribe my channel. Thanks for watching.